Hey guys, Defective Detective here with another video on Project Euler Series, and in today's video we are going to be doing Project Euler Problem 2. I fixed the voice problem mostly, but this time, well, I had to take a weird solution, so it is going to be sounding a bit echoey. Please bear with that. Sorry about that. Alright, so let's get started. As we normally do, we are going to work with TypeScript, and today's problem is largest prime factor, problem number 3. The largest prime factors of 13195 are 5, 7, 13, and 29. What is the largest prime factor of the number 600,851,475,143? Okay, so yeah, let's get started as we do normally. So we are going to do problem 3.md and we are going to copy the question as our usual routine kind of. And then I'm going to close this and open this, and again as pretty much usual. So yeah, now we are going to work on the concept. So basically one method which we could follow, let's just normal first method which we could do, a first thing which we could do is go through all the numbers less than the given one and check if they are prime, because we already know from the question that our number might be or might not be prime, but as far as we know, it is the question is finding the largest prime factor, so it is probably going to be non-prime or it is going to be composite. But problem is CPU is going to be on. Because 13195 loops, or let's just put this mega number, it would look more ominous. Loops is going to hurt. Actually it is a lot more, because because for prime you go on checking, you work to loop through all numbers again. So what is more efficient? Something a bit more efficient that could be by using half of it. So if you have noticed, the smallest number which might divide n is 2, right? Apart from 1. We know that even 1.5 can, but we are not talking about decimals or fractions, then every number can divide every number, right? That would be not great, so we could loop Let's take a number, for example 100. For example, we have 100 hundreds, like 50%, so 50, so 51 to 100. None of them divide 100, right? Right. So that proves it, and you can try it for every other number, every other even number. So yeah, that's pretty much a very useful thing. But how about we make this even more efficient? Now I exactly forgot the exact mathematical backing for it, but you guys can look that up a bit. We can loop through only the numbers less than the square root and work with it. Yeah, so I forgot the exact mathematical backing, but this is pretty even more efficient, because something better than halving, because square roots cut deeper than normal division by 2. For example, you have 6, or wait, you can have, let's say, 50. 50, and if you just square root it, it will come down to 10. 100, if you have 100, it will be half to 50, then you are gonna work all your way up till 50. So 1 2 3 4 5 6 7 8 9 10 till 50. Alright, on the other hand, if you work with square roots, you are gonna well get 1 to 10, and that's a smaller range where you could work with. So 1 2 3 4 5 6 7 8 and 9 10, and you get the factors already, which are 2 and 5, which is really great, right? Now we are going to talk about fundamental theorem of arithmetic. The name's pretty ominous, obviously, so let's just pull out the Wikipedia page. DuckDuckGo is awesome for this. So fundamental theorem of arithmetic. Pretty fast. Yeah. Totally not with typos. Yeah, so here's the Wikipedia page. I'm gonna link that down there. So it's a hyperlink now. Great, right? So basically it says that how do I put this? If you have n equals a times b times c times d times e times f. Too long an example, actually. Just 4. Let's just say to any power 1 or 2 or anything, where a b c r and d are primes. Also they might have powers higher than 1 as well, and m or n not equal to m can never be equal to a times b times c times d with the same powers as in n. Like, sounds pretty basic, right? Like, it is really basic, but still it is a fundamental theorem of arithmetic. So it basically says something about combinations, as you can get it. So combination of a times b times c, if we that is one unique combination. A squared times b times c is another unique combination, and all of them are prime numbers. So yeah, that's it. Now how does it come here? How does it come here? So let's have n pseudo. So like n first, which will be a times b times c times d times e. Okay. Now we are gonna make one n pseudo. So n pseudo equals a, or like n by a. So like we are looping through because a is the smallest. Like b is the second smallest, c is the second smallest. I'm just saying. So we find that first. Alright. So we basically get n equals a times n. So like n pseudo. N pseudo. That's it. That's pretty much it. Right. Now then we can apply this on to n as well. Alright, and so it goes on. That is it. And that is how we are gonna solve this like problem. Alright, so let's just do our map. Task map. Map. No, we are not in Mars right now. So 1, we loop through n, square root of n. Alright, and then we get an I. So we get that I, we are gonna check n modulo 0 equals 0. Wait, sorry, that was wrong. N modulo I equals 0. If not, return. Check. Like if it is, then we are going to put our second check, if prime. If it passes our test, we are gonna put n equals n modulo I, and then we are also going to do is largest prime equals I. That's it. And when we go to the final step, it might be possible that we are left with a bigger prime number. You never know, and it will probably be remaining. Yeah. So let's just say we are looping like this to make this number, according to our map, let's just copy that one. Okay, I didn't copy that one, I thought I did. Let's just copy that number and paste it here. Okay, that was too big a copy. Yeah, so now we know. So we first find 5. Let's just bring out the calculator because I don't want to do mental maths anymore. I'm bored. So yeah, that gives us 2639 divided by 7 now, so we get 377. Oops. Okay, so 377. Next, what do we get? We get 13, right? Because yeah, 390, 13. So we get 13, and we get the final one as 19. Wait, 29. But it is a prime number. It is a prime number, and since it is a prime number, it won't isn't included. 29 isn't found, kind of. So what we do is our 6th step, VVI, very very important, very very important. If at last we get n greater than largest prime equals n. So yeah, what about we get to the coding part now? That is pretty much the gist of it. Now if you want me to show the prime number, I will be doing that right here. So first we are going to make our function is prime, which takes in a number. Next we are going to make our function get largest prime, which is also going to take in a number of type number. And finally we are going to have console.log 13195. Get largest prime. Now we are going to put let largest prime equals 2, because I am a weird person, I guess. So first we already know that the largest prime which we know of is 2, but we should just keep it 0 or something. Yeah, that's better. Return largest prime. That's what we are gonna do. Now first let's just define the s prime, because it is way more important and way more useful, I guess. So what we are gonna do is, for let I equals 2, right? Because 0 you cannot literally divide it, and 1 is always going to give us, it will divide. So I squared is less than equal to number, and then we are going to have I plus plus, and now we'll check if by chance number modulo I equals 0, we are going to return false, and it just breaks out of the loop. Like let's just put a number like 5. 5 will be like, it starts with 2, doesn't divide till 0, 3 doesn't divide till 0, 4 doesn't divide till 0, 5 it does, but square root just exits pretty quick. Now if the number passed all the tests and turns out to be prime, let's say 101 is a prime number, and if you like run all of those tests, so it will be like till 10, because like it is less than equal to, that means like it will be stuck at 10, it won't go to 11, because 101 is something 10 point, like, yeah. So return true. That is it for now. We are going to loop let I equals 2, because again 1 is going to divide, this is also going to divide, so why not. And also largest prime is going to be reassigned anyways, so I times I is less than equal to number. Again same thing, and like old wine in a new bottle, that's what it is said. So we are going to loop again, but first we are going to check if it is a factor, because we are going to check if it is not a factor, then why are we going to like waste our time, like continue this time. We are not going to return here anyways. So yeah, now if a number comes here, so if number comes here means it is a factor of number. Similarly, if a number comes till here, it has no factors. So since according to our logic map, we are going to check if it is prime. So if no is prime, because if it is a prime it will return true, but if it is not a prime it will return false, and not false means true according to coding. Not always, actually, there are other options as well, but we are not going to go into philosophy right now. So if is prime, if not is prime I, it is going to continue. If number comes here as well, that means it is a prime factor. So we are going to set our largest prime equals like I, and then we are going to like do what do we do now? Yeah, so largest prime equals I, and then we do number equals number, and then we are going to divide it by I. So that gives us our n pseudo. So like number, let's just comment it here. Number is basically now the n pseudo. But we are going to put a last check, as I said. If number is greater than largest prime right, equals number, that should work actually. Yeah, well, yeah, I was testing some stuff out before. So let's wait. Let me just kill my calculator in the meanwhile. What? Did I make a mistake? I don't think so. The number's okay, and let's just follow the code. So I'm calling this function, and then I get largest prime equals 0, and then for 2, and there's a square root, I guess. Square root 13195, let's square root it. 114. So we are looping from 2 to 114. So if number is modulo 1, continue, and then we are going to check if is prime. Yeah, so let's just console.log I. Now you're seeing that and thinking, well, you have tried it before, what are you doing wrong? Actually, I was shooting the video again like 2 times and it failed kinda. Okay, it is divisible by 2. Big blunder. So if it is divisible, then it is not supposed to return. Sorry, I'm really sorry about that. So if it doesn't come 0, then it is supposed to continue. So yeah, I fixed it. It should be 29 now. 3, 5, 7, and then answer like 13, 5, 7, 13, 29. Yep. So we got the answer. So this is our code, and that shows us, let's just put it here, that shows us that is more important, more harmful than lol. Anyways, now we can like test on this number, which we were basically aiming to do. Like we should keep the jokes apart for now. Okay, I just wanted to copy the number. So yeah, let's go. I might want to remove the console.log. It is going to be pretty spammy then. But I'm gonna do some bonus stuff as well. Okay, so we got our answers, guys. This is going to answer. So yeah. Now let's just do something bonus, because we shouldn't just let it like that. So we are going to like also sort the number. We won't need to sort it, but we are also going to return the array. So like const prime array equals this. Now I need to specify the type. Primer dot push largest prime, because by now I is already assigned, like largest prime is already assigned. So yeah, now I'm gonna return an object. So largest prime array, I don't know. So we should get an object, because why not? Yep, that gives us, oh wait, so yeah, time to do another fix. I forgot that. So it looks like this if statement is being called most of the time or every time, because in both of the examples we see this. uh, Here we go. So that's it for this video, guys. Hope you guys had fun or at least learned something new. That's more important. So yeah, see you guys next time in the next video. Signing out. Peace.